All right, here is a video on how to solve for each of these equations as given here in question number 2. You see a ratio, solving for an angle situation, and basically you need to tell me what that angle is. And considering what we're learning about the cast rule, each one of these angles, whether they be a positive angle or a positive ratio or a negative ratio, could actually produce two possible results. Okay, each one of them. And I'm going to go into explaining that. So I figure maybe I'll start with C, and then we'll do letter D after as well. So for a cotangent theta is equal to -3, what we're being asked here to find is what theta is. So, you can do a calculation, and you can say theta is the cotangent inverse of -√3. Right, because you're trying to find that angle, so you can just punch it in here. You go 3 root, turn it negative, and then we got to go inverse cotangent. And I got -30. Okay, and what I'm actually discovering here is that I have 30 degrees, and my answer is actually negative. And you think about what cotangent is. Cotangent is the reciprocal of tangent, right? And if you think about, when we talk about CAST, cotangent is instead of opposite over adjacent like tangent is, it is adjacent over opposite. And even still, it's positive over here and positive over here. But the thing is, our situation doesn't actually call for positives. We're calling for negatives. So where is it negative? Well, if it's positive in those two spots, it's negative in these two spots. Okay, so we have to calculate what this angle would be in each of those spots. Well, the cool thing is you can now look at this angle, and you can assume then that this angle is the related angle. You draw this as a related angle into these particular spots. So if I try to expand out just for a little bit here, bring this out, and oops, let's try this one more time. And I bring this out. Right, then essentially I'm drawing that related angle here. Let me get this here. Right. Right there and right there. Okay, and it is 30 degrees. So I'm going to put in that this is 30 right here. And it exists in these two spots, like this. So what angle value will, this angle value of 30 would actually create a ratio of √3, right? Well, if you think about it, this is a special triangle, right? And the special triangle should be labeled out as 1, √3, and 2, right? And in this particular area, on this first triangle I'm drawing on the top left here, the measurements are actually like this. This is a -3 here, right? And from this angle of 30 degrees, I have opposite over adjacent, right? Opposite over adjacent, which would be tan. But this is cotangent, so we have to think adjacent over opposite. So that would be, cotangent of 30 degrees is equal to adjacent over opposite. And in this case, the adjacent is the -√3, and the opposite is 1. And so that is our first related angle. It works out. Okay, you could see we end up with -√3, just like this. And so if you wanted to figure out what this theta actually is, well then theta number 1 here right? Theta number 1 is the primary angle that would get you to here. Okay, and so this primary angle, maybe I should do this in a different color here. Yeah, that'd be better. Let me get the primary angle that would get you this, theta number 1, is this total distance all the way to there. It'd be a full 180 degrees, subtract the related angle of 30 degrees. So our first angle, theta 1, is 150 degrees. Okay, this has a cotangent theta of negative root 3. The other one is what would be this angle from the initial arm all the way to the terminal arm here. Right? Let me draw that one more time. Or not. Yeah. The other one would have to bring you all the way around. So if you think about that, then I'm going to come in with a different color one more time. And this time we are going to come all the way around and get to here. And you're like, how far is this distance? Right? Well, this distance is a full 360 degrees, theta 2. And we're going to subtract the related angle of 30 degrees. And so I would have 330 degrees. That would be my theta 2. So the two angles that produce this are the first one in the blue, 150 degrees, and the other one, 330 degrees. So if you look here, you should see 150. Oh, sorry, the screen jumped. Right, we should see 150 and 330 down where the answer key is, and that is right there. Okay, so let's talk about letter D here. And with letter D, I'm going to do the exact same steps, right? But there's just a little bit of a hint, a hindrance. One more thing is we actually need to isolate the tan theta first. So in this case, I'm going to send that root 3 to the other side and the negative 1 to the other side, and then do it in the right order. So I'm going to say, root 3 tan theta is equal to positive 1, right? Now the 1 was brought to the other side is equal to positive 1. And then I'm going to have to divide out the root 3 on both sides, and I get tan theta is equal to 1 over root 3. So if tan theta is equal to 1 over root 3, then I'm sure you understand that if I wanted to find theta, I'd have to do tan inverse. And theta, and what we're talking about theta here is that related angle. It's 1 over root 3. So 1 divided by 3 root is equal to this, and we have to do tan inverse on it, and that's right there. And that's 30 degrees. Okay, but this is the related angle. This is the angle inside that would create this. Remember, it needs to be positive, and we're going to think about where tan actually is being positive. So I'll just write it right here. When is tan positive? Tan is positive here, and it is positive here. Okay, because the A section is where all the ratios are positive. SOCA, TOA, even their inverses, their reciprocals will also be positive in the A section, and the tan is positive over there. So if we were to draw in the related angle of 30 degrees, for instance, right here, right, there's your 30 degrees. Okay, then, okay, that's right there. That's 30 degrees. So I know theta 1 is right there. Theta 1 is equal to 30 degrees. But the other one is all the way around to here, where I draw another 30 degrees, right? And this one, you can label it and everything. But to get to this, the one in the T section here, which is our third quadrant, this one is 180 plus 30 degrees, right? Theta 2, which is 210 degrees. Okay, so you can see both of the values found there. You have theta 1 being 30 degrees right there, and theta 2 being 210 degrees. That would take you all the way around to here. So theta 1 is 30, theta 2 should be 210. That's for letter D. Right there. Okay. And, sorry, I'm just trying to find some more space to do each one. I guess I'm going to have to rip this. Hold on. I'm going to do this on the bottom. Okay, and here's the here's letter E. I can do letter E as well for you. And in letter E, it's actually asking 2, and then cosecant theta subtract root 8 is equal to 0. So we're going to follow our steps just to isolate it first. And we're going to say cosecant theta is equal to root 8. Right? And there's a 2, of course. And we're going to have to divide 2 from both sides, and you get cosecant theta is equal to root 8 over 2. And you know what? That's a radical of root 8. You can simplify it, and you can write it as cosecant theta is equal to 4 times 2, right? That goes on the inside. So that is 2 root 2 over 2, and these 2's cross out. And I could say cosecant theta is equal to root 2. Okay, well, I've gotten this far. I also have to find theta, though. So that is the inverse cosecant of root 2. And, right, clear that. 2 root gets that, and cosecant inverse is 45 degrees. Okay, so you know, at what point is cosecant positive, right? Because this is, you can see it's positive here. When is it positive? Well, we do the cast thing again, C-A-S-T, right? And cosecant is the reciprocal function of sine. So when is sine positive? Sine is positive in this quadrant, and it's positive in this quadrant. Okay, so we're going to draw this 45 as a related angle. The first related angle in the first quadrant, that's 45. That's, boom, right there. That's my first theta. It's 45 degrees. So that's going to be my first answer. The other one is, 45 degrees, but in this quadrant. This will be theta 2. Okay. And if we connect this over, this one will be 45 degrees in this particular quadrant. Measuring fully around, this would be 90 plus another one. So let's just list them out. Theta 1 is equal to 45 degrees, and theta 2 is equal to 90. Or you can say a full 180, and we're going to subtract the 45. Yeah, that's better. 180 subtract 45, and that's 135 degrees. Now I'll put you into the second quadrant. So these are my two answers for letter E, 45 and 135. Let's just see if that checks out. It does. Okay, so I hope these solutions find you well, and that you can use these and be successful with them in doing your work. Okay? Good. Bye.